Hey y'all, welcome back. Tonight's homework's all about the product rule. And so we're starting to learn how to differentiate functions that are combinations of some of the more elementary functions we've dealt with. The power rule is useful for differentiating any algebraic functions. And we've got a couple of transcendental derivatives that we know now. But up until today, you were really only able to differentiate a sum or difference of all of those functions. And with the product rule, we can now differentiate a product of two functions. We're not quite yet at the point where we can differentiate a quotient, but that is what we're going to look at in the next lesson. So let's talk about just the product rule in general. Here is if you're trying to differentiate a product of two functions, what you have to do is differentiate one of the functions. So let's say we differentiate g first. We're going to multiply f times g prime and then add that to f prime g. So in other words, you have to differentiate each of the inside functions, but whichever one you're differentiating, like let's say we differentiate the second function first, you want to multiply that by the first original function, okay? So notice g prime. Now, in whatever the other term is, you're going to differentiate the first function and multiply that by the second. So the order here doesn't really matter because addition is commutative, but I'm going to try to stay consistent and try to differentiate the second function first every time. So let's get started here. With f of x being 3x squared times sine x, I'm going to use 3x squared as my first function and sine x as my second function. So the derivative of f of x is going to be the first one, that 3x squared, times the derivative of sine. We know the derivative of sine is cosine, plus the derivative of the first one, which with the power rule we can compute as 6 times x, times the second function, sine x. Yeah, there you go. That's all there is to it. So I guess really the hardest part of this, other than just knowing your power rule and transcendental derivatives, is just kind of remembering how to actually compute the derivative here, remembering this product rule. So let's do letter B here. So the first function that we're going to identify is e to the x, and the second function is going to be cosine x. So the derivative of g here is going to be the first function, e to the x, times the derivative of the second one. Now that's negative sine x. So usually with this derivative of cosine being sine, I like to go ahead and move that negative sign out to the front of the expression. It just cleans it up a little bit. And while it's not totally necessary to do that, your answer is going to look a lot nicer if you do. So I'm going to get rid of this extra set of parentheses and write this as negative e to the x. Okay, the negative is still coming from the derivative of cosine, but it just looks a little nicer when you write it like this. Plus the derivative of the first. Now, e to the x is that special function that is its own derivative. So we are taking the derivative here, it's just that nothing really happens. And then multiply that by the second function. Part C, we've got sine x times natural log x. So these two functions are going to be pretty well separated here. We got sine x as the first one, and we got natural log as the second one. So I'm going to move down here, just to give myself a little bit more space here. H prime of x is going to be the first function times the derivative of the second function, 1 over x. And you're welcome to write that as x to the negative first, but I think what you'll see like in multiple choice items is that these two expressions will be combined, and we'll write that as sine x over x. So just be aware that you may see it written like that. And then our next expression is going to be this derivative of sine x, which of course we know is cosine x. We've already established that. And I'm almost out of space here. Yeah, I did not give myself very much room to write this one out. So cosine x times the second function, natural log x. So Yeah, we'd have plus cosine x times natural log x is our answer. Number 2. Okay, so this is kind of like what we did in the notes. During the lesson, we examined a product of two binomials and differentiated it two ways. First, by multiplying the two binomials together, and then secondly, by just using the product rule. Now, this is going to ask us to do it kind of the opposite, in the opposite order, where we're first going to use the product rule, and then we're going to do the algebra first, and then use the power rule. So first, let's use the product rule. In this example, we've got 4x cubed plus 5x is our first function. And we've got 3x squared minus 7x as our second function. Those are our factors. So to differentiate this, to find f prime, so f prime of x is going to be the first function, 4x cubed plus 5x, times the derivative of the second function, which is 6x minus 7, plus the derivative of the first, which would be 12x squared plus 5, times the second function, 3x squared minus 7x. Ugh. This looks like, a great example of like maybe why you would want to not use the product rule on a problem like this. Because now we're going to have to go ahead and multiply all this stuff out. Yeah, so we've got 4x cubed times 6x. So let's see, 4 times 6 is 24, x to the fourth. And then we got 4x cubed times negative 7, so that'd be minus 28x cubed. Really counting on my mental arithmetic being correct here. Plus 30x squared minus 35x. Okay, so all of that just came from the first product. Right? Now we've got plus, and then we need to multiply these two binomials together. Let me move this up a little bit. 12x squared times 3x squared is going to be 36x squared. And then I've got 12x squared times negative 7x. So that'd be minus, 7 times 12. Well, let's see. 5 times 12 is 60. And then we got two more 12s, 24. So 60 and 24 is 74. Gosh, I hope I did that right. 74x cubed. And then what do we have after that? 3x squared times 5 is going to be 15x squared. And then 5 times negative 7x is going to be minus 35x. Oh, wait a minute. 60 plus 24, that's going to be 84, minus 84. My bad. Yeah, it's 12. It'd be 60 and 24 is 84. Okay. So, yeah, this four-termed polynomial here is going to be what we get from multiplying this second product out. So now we're just going to combine our like terms. It looks like the only, let's see. Oh, wait a minute. Looking back, hold up. 36x to the fourth. Whew. All right, I was like, something's missing here. Okay, so we got 24x to the fourth plus 36x to the fourth. That's going to be 60x to the fourth. And then we've got our two cubic terms. All right, we've got the minus 28x cubed minus 84x cubed. So that would be minus, 20 and 80 would be 100, but then we got 12 extra, so that's going to be minus 112x cubed. Then we've got 30x squared minus 15x squared, or plus 15x squared, so that should be 45x squared. And then our last one here, let's grab a different color. So we got minus 35x minus 35x is going to be minus 70x. Whew. All right. Did not really enjoy that very much. So let's see how this might be different. And maybe I'll use a different color here to partition these. How would this be different if we actually did the multiplication first and then did the differentiation using the power rule? So first I'm going to multiply those two binomials together. So I'm rewriting f of x here as 12x to the, wait a minute, is that right? Oh yeah, 12x to the fifth minus 28x to the fourth plus, am I going to run out of space again? Oh no, there we go. Plus 15x to the third. And then finally, we've got minus 35x squared. And so if I want to differentiate that, I can just use the power rule all the way across. 5 times 12 is 60. 28 times 4, let's see, 28 and 28 would be 56. 56 and 56 would be 112, so minus 112, x to the third. 3 times 15 is going to be 45. And then 35 times 2 is 70. So notice we do get the same answer both ways. It's really up to you which one you like better, but I think it's pretty obvious which one took the least amount of work. And that's going to be using algebra first and then using the power rule. And that's not always going to be the case. And there's going to be, if you have any transcendental derivatives or functions thrown in the mix, you don't really get a choice as far as what you want to do first. You kind of just have to make a mental decision on what's going to be easier. And I think on a problem like this, I'd rather do the algebra first and then use the power rule and just kind of avoid the product rule altogether. But you'll get the right answer either way. For number 3, we're going to use some more product rule here, and we're going to use the values given in the table. So we've got a value for f of 3. So just to be clear what this is giving us, this is f of 3 here. This is f prime of 3. This is g of 3. And this is g prime of 3. So let's see. H of x equals the product of f and g. So I need to find both the derivative of h and the derivative of h at 3. So I'll find the algebraic expression that gives us the slope at any point, and then we'll just use the table to find. Oh wait, can we even find it? Oh yeah, I guess we'll just have to do it in terms of f and g. So yeah, let's find the derivative of h, which will be the first function, f of x, times the derivative of the second function, plus the derivative of the first one, times the derivative, not the derivative, but just times the second one. So that's our h of x, we got that, or h prime of x. Now we want to do h prime of 3. So we want to find the slope of this function when x is 3. So that'll be f of 3 times the derivative of g at 3 plus the derivative of f at 3 times g of 3. And all those values are going to find in the table. F of 3 is 2. G prime of 3 is 5. F prime of 3 is 6. And g of 3 is negative 9. So we've got 10 minus 54. It's going to be negative 44. So the derivative of h at 3 is negative 44. All right. In letter B, we're going to approach this basically the same way, except instead of f of x, we have x squared. So h prime of x, again, will be the first function, which is going to be the x squared, times the derivative of the second, plus the derivative of the first, which is 2x, use the power rule on that x squared, times the second function. All right, so that's the first part here. And then we want to find the slope at 3. So we've got 3 squared times 5 plus 2 times 3 times g of 3, which is negative 9. All right, so we got 9 times 5 is going to be 45. And then 2 times 3 is 6. 6 times negative 9 is going to be minus 54. So the difference between these two numbers is 9, and since the bigger one is negative, this is going to equal negative 9. So the derivative of h at 3 is negative 9. I feel like this homework is really pushing my arithmetic skills here a little bit. Really got to focus and make sure I'm doing my addition and multiplication correctly. All right, h of x is now 8 times f of x plus 3 times g of x. So this is not going to be a case where we need to use the product rule. We can just differentiate each term separately. So the derivative of h is just going to be 8 times the derivative of f plus 3 times the derivative of g. So at 3, we're going to have 8 times 6 plus 3 times 5. I'm getting those values again from the table. So yeah, 6 times 8 is going to be 48, and 3 times 5 is 15. So the derivative or the slope of h when x is 3 in this case would be, well, it'd be, let's see, if it was just 48 plus 10, that'd be 58, plus 5 is going to be 63. All right, letter H. Or no, letter D. We're still working with h of x, though. So the derivative will be the first function, so 4x, times the derivative of the second, plus the derivative of the first, which would just be 4. Derivative of 4x is 4, and the slope of 4x is 4, times the second function. Now I want to evaluate when x is 3. So I have 4 times 3 times f prime of 3, in other words, the slope of f at 3, and that's going to be 6, plus 4 times f of 3, which is 2. So this is going to equal, let's see, 12 times 6 plus 8. 12 times 6. Okay, well, 10 times 6 is 60. I'm just kind of narrating how I get there. 10 times 6 is 60, but I got 2 more 6s, so that's 12. So 60 and 12 would be 72, plus 8 is going to be 80. For letter E, I'm going to use product rule one more time here. First function is e to the x. The second derivative is f prime. The derivative of e to the x is just e to the x, and then we're going to multiply that by f of x. So if we plug in 3, we're going to have e cubed times, let's see, f prime of 3 is 6, plus e cubed again, times f of 3 is 2. So I've got 6e cubed plus 2e cubed is going to give me a total of 8e cubes. Number 4, now we're using the graph. Now, we did some problems like this in the notes, and so I want to approach it kind of the same way, which is to first analyze all the slopes of all these little segments. So let's do that first. So the slope of this horizontal line is going to be the same as the slope of any horizontal line, which is 0. Okay, so there is a slope there, it's just 0. And then the slope of the next one, I'm going down 1, 2, 3, 4, 5, 6. My delta y is 6. My delta x, 1, 2, 3, 4, 5. So let me just double check my count here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So the slope here is going to be down 6 over 5, or negative 6/5. On the next segment, we've got a slope of up 1, 2, 3, 4 over 2. 4 divided by 2 is 2. On the next segment, I'm going down 1 over 2, so that'd be negative 1/2. The next one's just 0. And then the next one is down 1, 2, 3, 4, 5 over 3. So negative 5. Let me double check that. 1, 2, 3, 4. Yeah, negative 5 over 3. The other thing to note here is that all of these points where the lines are connecting, so I'm talking about like all of these points, and I'm also going to include the endpoints here. at all of those locations, here, let me pick a color that's a little easier to see. The slope is going to be undefined. So if I ask what the slope is at any of those points, you're going to say it does not exist. And so that's going to happen anytime you have a sharp corner. And when I mean sharp corner, it really has nothing to do with the angle between the two lines. It's just the fact that the slope doesn't gradually change. And so what I mean by that is that at any of these points, for instance, look at where x is 2. The slope changes instantaneously from 2 to -1/2. It's not changing gradually to where you could find a point anywhere in between where the slope's in between 2 and -1/2. It just changes suddenly. So anytime you have a sudden change in slope like that, the slope's not going to exist. Okay, so let's evaluate all these. F of 4 is just going to be the value of the function when x is 4, and that's going to be -2. So that's going to be the y coordinate on the graph. Part B is looking for the slope where x is 4. Okay, that's going to be one of our undefined places. So this is just not going to exist. Letter C, the derivative where x is 8. Okay, so I look at 8 and I see that the slope along that segment is -5/3. The slope at -7 is that horizontal segment over here, so the slope's just going to be 0. The slope at 0, there's another place where the slope is undefined. I've got a sharp corner here. And the slope at x equals -2 is, it's going to be down in this little interval here, where the slope is going to be -6/5. Okay, these next two questions are going to have us interacting with this graph, I think. Yep, and combining it as a product, where the other factor is like some other function. So h of x is x squared times f of x. So h prime will be the first function x squared times the derivative of the second plus the derivative of the first, which is 2x, times the second. So if I want h prime of 3, or the slope when h is 3, I'm going to get 3 squared times the slope when x is 3. So that's going to be over here. The slope is -1/2 plus 2 times 3 times the value of the function when x is 3. So I'm still looking where x is 3, and it appears as though it's like -1.5. So let's see, or maybe I'll rewrite that since I don't want to kind of mix fractions and decimals here. I'll write that as -3/2. Okay, so let's simplify this now. We got 9 times -1/2, so that's -9/2. And then over here we have 2 times 3 times 3 divided by 2. So the 2's will just reduce to 1, and that means I just have -9. Okay, so 9 is the same thing as 18/2. So 18 and 9 is going to be 27. So h prime 3, or the slope, or the slope of h when x is 3, is going to be -27/2. For letter H, we have a function g of x, which is the product of natural log x and f of x, which is the graph that is pictured here. And we want to know what's going on when x is -7. So that's going to be right here. Okay, so let's find the derivative first. We'll use the product rule to do that. So g prime will be the first function, natural log of x, times the derivative of the second, plus the derivative of the first. So the derivative of natural log is going to be 1 over x times the second, f of x. Okay, so let's go ahead and plug in -7 to our functions. We have the, what is this? The natural log of -7? Wait a minute, what's going on here? Okay, well, we'll come back to that. And then we've got f prime of x. Okay, so that is, we can kind of stop here, but we'll continue this on just for practice. So the slope at -7 is going to be 0 plus 1 over x, that'd be 1 over -7, times f of -7, which is going to be 1. Okay, so wait a minute here. We've got the natural log of -7. This has no value because -7 is outside of the domain of natural log. So this whole thing is just not going to exist. Even though we're multiplying by 0, it kind of seems like maybe this would just be 0 minus a seventh, and you get -1/7. But because this natural log of x, we've got to make sure that we don't have any domain problems here. And we do have a domain problem because -7 is not in the domain of natural log. So we're going to just say this doesn't exist. Okay, we only got a couple questions here left. Number 5, just another case of using the product rule, but we're actually going to have to use it twice. Okay, because we've got a product here with 4x being the first function and sine x being the second function. And then we got another product where x squared is the first function, cosine x is the second function. So let's we'll just kind of go slowly here and find one little derivative at a time. So I'll start with that first product. I've got the first function 4x times the derivative of sine, which is cosine. Okay, plus the derivative of 4x, which is 4, times sine. Now for the second one, I am going to have to differentiate cosine x, and I know that's going to give me negative sine x, so I'm just going to be prepared to make this a minus. So minus the first function x squared times the derivative of cosine, which is negative sine, but I've already accounted for the negative here, so it just kind of looks a little nicer, I think, when you write it like that. You could just write it as plus x squared times negative sine x, but then you got another set of parentheses here, and we've already got enough parentheses as it is, and I'm already being a little sloppy with my parentheses here. I guess I was pretty good otherwise. Okay, so my last term here is going to be plus the derivative of the first, which would be 2x, times the second, which is cosine x. And I'm not even going to bother trying to simplify or factor or anything. I'm just going to leave my answer just like that. Okay, number 6. Another limit definition question, and I'm going to continue to hammer you with these. The big clue is that we've got this h approaches 0. We've got an h in the bottom. This is where your mind should immediately be going to the definition of the derivative, which is that the limit as h approaches 0 of f of x plus h minus f of x all over h is the derivative of f. So basically what you have to do is try to identify what f is and differentiate it. It should be pretty obvious, though. In this case, f of x is just cosine x. So this is going to equal the derivative of cosine x, which, as we know, is negative sine x. That's all there is to it. These problems are really not that hard as long as you know like what you're looking at. So I'm going to keep throwing these at you because I want to make sure that on the AP test, you get that right. Number 7, we got one last product rule question here. So here's my first function. Second function is going to be e to the x minus 1. So we're going to multiply x squared by the derivative of e to the x minus 1, which is just e to the x. The derivative of 1 is just 0. And then we're going to do plus the derivative of the first function, which is 2x, times the second function. And I'm looking at my answer choices, and this is what's going to happen a lot of times with multiple choice items is, a free response, you don't have to simplify, but the multiple choice, your answers are going to tend to be simplified, or at least somehow regrouped. So basically our goal here is to figure out which one of these is equivalent. So I'm going to distribute the 2x and just kind of see where that takes me. X squared times e to the x plus 2x e to the x minus 2x. And I might have to factor something, but actually it doesn't look like anything. There's no GCF here other than 1. Looking at these terms, I don't see any common terms. So my answer should look something like this. And actually I do see that I've got the x squared e to the x, the 2x e to the x, and the minus 2x, so our answer is C. And that's going to wrap it up for tonight's homework. As always, please reach out if you have any questions. Thanks for watching, and y'all have a great day.